All right, well, it's 2 o'clock. I'm going to go ahead and get us started. Thank you for joining us for part of Texas A&M's Virtual Earth Month. This is our third such event. My name is Kelly Wellman, and I'm the director for the Office of Sustainability here, and I'm very delighted that Dr. Dessler agreed to speak to us today about, and in fact, the title is, What's the Real Cause of Climate Change? Before I turn it over to Dr. Dessler, just kind of go over a couple of our logistics. We are recording this so that we can upload it later. Everyone's been basically, you're on mute. If there is a question that you think of during the talk, put that in the chat. I will moderate discussion for the Q&A at the end and relay those questions and or comments. And I have turned on the Zoom's auto transcript, which works fairly well. There's sometimes the words get a little creative down there, but if you don't want to see the closed captioning, you can go down to the bottom of your screen and there's an option for you to hide that if that is something you choose to do. So with that, I'm going to introduce Dr. Dessler. Andrew Dessler is a climate scientist who studies both the science and politics of climate change. His scientific research revolves around climate feedbacks, in particular how water vapor and clouds act to amplify warming from the carbon dioxide that humans emit. During the last year of the Clinton administration, he served as a senior policy analyst in the White House Office of Science and Technology Policy. Based on his research and policy experience, he has authored 2 books on climate change: The Science and Politics of Global Climate Change, A Guide to Debate, and Introduction to Modern Climate Change. This latter book won the 2014 American Meteorological Society Louis J. Batten Authors Award. In 2012, he received the AGU's Ascent Award from the Atmospheric Sciences section to reward exceptional achievement by mid-career scientists. In recognition of his work on outreach, in 2011, he was named a Google Science Communication Fellow. Prior to his work on climate, his research focused on stratospheric photochemistry. He authored the book, The Chemistry and Physics of Stratospheric Ozone, about his work on that subject. He is a fellow of the American Association for the Advancement of Science and the American Geophysical Union. He is presently a professor at Atmospheric Sciences and holder of the Rita A. Haynes Chair in Geosciences at Texas A&M University. His educational background includes a BA in physics from Rice University and a PhD in chemistry from Harvard University. He also did postdoctoral work at NASA's Goddard Space Flight Center and spent 9 years on the research faculty of the University of Maryland. Prior to graduate school, he worked on Wall Street in the energy group at the First Boston Corporation, doing mergers and acquisitions analysis. Dr. Dessler lives in College Station, Texas, with his wife, 2 kids, and 2 lazy dogs. With that, I'm going to stop my share, Dr. Dessler, and turn it over to you.
Okay, thank you. Let me share my screen. Let's see. There we go. Okay, so does this look okay? You can see sharing correctly? Okay, great. So thank you. Let me say it's great not to be there wherever you are. In these difficult times, perhaps climate change, talking about climate change is a good way to change the topic from what's depressing everybody else. So I'm going to talk about climate change. And I'll go over some of the basics of climate change. And one of the things I'll also emphasize is why we're in this situation from a policy perspective. So I always like to begin, if you don't remember anything else about the talk, climate science in 10 words. It's real, it's us, it's bad, scientists agree, but there's hope. Okay, so we can solve the problem. I don't want anybody leaving thinking that there's nothing we can do about it. There are things we can do. There may be, we may think we don't want to do them, but trust me, they're better than the alternative of not doing them. And we'll talk about that later. And I'm actually going to go over all of these in, say, 40 minutes. Some of them more quickly than others. But so let's begin and we'll do a quick tour through all of these. We'll start off with it's real. Okay. So I'm not going to spend a lot of time on this, but I'll show you one plot. This is temperature, which I'm guessing a lot of people have seen plots that look like this. This is measured from thermometers all over the planet. And since about the middle of the 19th century, we've had enough thermometers we can come up with an estimate of the global surface temperature. And this is what it looks like. And this is referenced to the mid 20th century. And it doesn't take a PhD in statistics to see that the temperature is going up. Okay, so the Earth is warming. There's at this point, very few people dispute that. And we have not just thermometer data, we also have satellite data that shows it's warming. If you look at ice everywhere on the planet is melting, which is what you would predict if the Earth were warming. So everything we see is consistent with the idea that the Earth is warming, and our best measurements, these thermometers, give us a good quantification. And the evidence is so overwhelming that the IPCC, which is a body that assesses climate science, calls the warming unequivocal, meaning beyond doubt. So like cigarettes cause cancer, DNA is a double helix, there's certain, quantum mechanics, there are certain things that are so well understood in science that they're considered to be true beyond doubt. And this is one of them. Okay, so that's all I'm going to talk about. It's real. If you have a question about it, feel free to put it in the chat, and we'll talk about it after the talk. It's us. Okay, so this is from the movie We Trace the Call. It's coming from inside the house. So, we've looked at the warming. It's us. So how do we know it's us? And again, I'm not going to spend a lot of time on this. This is a very, you could spend an entire semester talking about what we call detection and attribution studies. But the way to think about this is to think about being a detective. So you're a detective and you're investigating a crime. A house has been burglarized. Now, the first thing you know is the house didn't burglarize itself. So when we look at climate change and we see the warming, there has to be a physical explanation for that. You can't say, it's natural. Saying it's natural is not a physical explanation. You have to be able to assign a physical process to the warming. Now, we can identify all the things we think can change the climate. These are things that change the climate before humans, as well as what we think humans are doing to the climate. And we can go down the suspects, just like a detective would do. You go down the suspects one at a time, and you say, can this suspect do it? Can this suspect do it? And so we can look at, for example, the orbital variation. So the Earth's orbit is not a perfect circle. In fact, it changes shape. It's an ellipse that changes shape over time. And we know, for example, that the orbits are what's responsible for ice ages. But we also know the orbits change very slowly. So that's a 10 to 100,000 year process. So that's too slow to cause the warming of the 20th century. Volcanoes, we know when volcanoes go off. We don't think volcanoes could be causing the temperature change. Solar variability, we know the sun changes how much energy it's put out. If the sun were getting brighter, you could therefore argue that that was causing warming, but we're actually measuring the output of the sun. So we actually have measurements. Sun is not getting brighter. So that cannot be causing the warming. Then you have something called internal variability. This refers to things like El Nino cycles. These are things that are not forced. So the Earth's climate system is so complicated that it can vary on its own. It can warm and cool without any external forcing. And El Nino is a good example of one. And we understand how El Ninos work. And nobody has evidence that it's internal variability, or even a theory about how internal variability could explain all the things we see in the warming climate. And so I put a dash through that because it's impossible to disprove it. I can't disprove it, but I can say nobody has a theory. Nobody has any evidence. So it's kind of like a suspect who doesn't have an alibi. Suspect said he was home playing Xbox by himself. Nobody saw him. He can't prove he's doing it. But then on the other hand, there's no evidence saying this person did it. You would be very hard pressed if you're on a jury to convict that person of a crime. And then we have greenhouse gases. So greenhouse gases I like to describe as the world's dumbest criminal. Is the criminal that drops his wallet at the crime scene, leaves fingerprints all over the place, was videotaped carrying the stuff out of the house. He was bragging to his friends he did it. When he was arrested, all of the stolen merchandise was in the trunk of his car. And he told the police, yeah, I did it. So, there's a mountain of evidence that greenhouse gases emitted mainly from human activity are responsible. So let's just talk briefly about those. First of all, there's theory. We understand how greenhouse gases warm the climate. This is not new. Arrhenius in 1890s worked this out. We know we're adding greenhouse gases to the atmosphere, so by burning fossil fuels. So just given those two things, we know we're adding greenhouse gases, and there's theory that if you add greenhouse gases, you warm the climate. You should expect the climate to warm. And indeed, we see it warming, and it matches what we expect in timing and in magnitude. In addition, there are what we call fingerprints, which is the entire Earth is not warming equally. So for example, the stratosphere, which is the upper atmosphere, is actually cooling. And that is actually a prediction of greenhouse warming, that the lower atmosphere warms and the upper atmosphere cools. And so that's a fingerprint that identifies not just the amount of warming, but how the warming is distributed. In addition, the paleohistorical record, if you go back to previous climate change in the paleoclimate record, many of those, or most of them, are associated with changes in greenhouse gases in a way that suggests it's greenhouse gases that are causing the warming. So if you put this all together, essentially the entire scientific community has concluded that humans are now the dominant driver of multi-decadal climate variations. So we're in the driver's seat and we got our foot on the gas. Okay, so that brings us to it's bad. And I've been showing this slide for a while. I think it's losing its cultural relevance. Hopefully everybody knows who Michael Jackson is and his album. If not, let me know in the chat. I'll have to find a different slide. So why is climate change bad? Okay, so you might think, who cares? Climate's gonna get a little warmer. I'll just wear tank tops. So let's talk a little about that. So first of all, let's look at what we predict. So this plot shows there are two axes. The x-axis down here shows year, and this is the temperature increase relative to essentially the late 20th century. And so you can see that there are two scenarios. This is a scenario where we burn all the fossil fuels we can find in the world. This is a scenario where maybe we don't. And we don't really know what the world's going to do. But you can think the future will fall probably somewhere between these optimistic and not optimistic scenarios. And if you look at the y-axis, you can see the warming. And so we predict a couple of degrees warming over the 21st century. So maybe we'll get 4 degrees of warming, maybe we'll get 8 degrees of warming. And again, you might say, who cares? And so let me begin by saying that your intuition of what this is global average temperature. And your intuition is not very good. While local temperatures can vary a lot. So today might be 10 or 15 degrees warmer than yesterday, and tonight might be 20 degrees cooler this afternoon. Global average temperatures are very stable. And what seem like small changes in global average temperature actually correspond to huge changes in the environment. So to give you an idea of what we're talking about, let's look at the last ice age. So this is last glacial maximum. This is 20,000 years ago. You'll see 20,000 years ago, there was an ice sheet covering the upper half of North America. And this ice was thousands of feet thick. I mean, it was a lot of water was stored here, so much that sea level was 300 feet lower. That's a lot. Now, if you ask yourself, how much cooler was the last ice age? And I'll say that in addition to having a big ice sheet, the flora and the fauna were completely different. Ecosystems look different, animals were completely different. So now I'll say, how much cooler do you need to cool the planet to get an ice age? And the answer is an amazing 9 degrees. If you cool the global average temperature 9 degrees, you end up with an ice sheet. So think about, really think about that. 9 degrees is enough to completely reshape the planet. So let's look again at what we predict for the 21st century. So we're predicting warming that is of the same magnitude as the amount of warming we've had since the last ice age. And it's actually worse than that. It's worse than that because it took us 10,000 years to warm out of the last ice age. This is 100 years. So it is not just a huge amount of warming, it is incredibly fast. And while I don't plan on living to 2100, today's students easily could live to 2100, and certainly everybody's kids could live to 2100. So this is something that a lot of people on this call may live through this. And trust me when I say this could be a very bad ride. All right, you are gonna run the experiment. Now let's talk one more thing about why these climate changes then are so bad for people. And the number one reason is we are adapted to our present climate. So we've built a lot of long-lived infrastructure that are tailored to our permanent or our present climate conditions. So let me give you an example of what adaptation means. So imagine you have a lake, you live next to a very beautiful lake, and so you put a pier into the lake. Now, once you put the pier into the lake, you are adapted to that lake level. If the water level rises, your pier is underwater. If the water level goes down, your pier is stranded and you've lost the value. And we have millions of these adaptations all over our society. We have built into our present climate. As the climate changes, these adaptations will no longer be effective, and we will have to spend money readapting to the climate. So it is going to cost a lot of money. And if we don't spend money, then you're going to have a lot of suffering because people will not be adapted to the climate. So let me give you an example from my hometown, Houston. So I grew up in the Meyerland area of Houston, and we'll talk a little more about Meyerland in a second. So anybody who is from Houston or lives in Houston now or pays attention to Houston knows that Houston has had a lot of extremely heavy rain events in the last few years. So 2015, 16, 17 each had a 500-year flood. We just had another one just north of Houston last year. And so your question is, I mean, how is that possible? And the answer is it's climate change. One of the longest standing predictions of climate science has been that heavy rainfalls are going to become more frequent. Indeed, we see that in the data. And so these events have all been tied to climate change. Now, the important thing to understand again is Houston is adapted to a certain amount of rain. So when we built Houston, we built bayous, we built flood control systems that were set up to handle a certain amount of rain. If the rain exceeds that, the city floods. And during, for example, Hurricane Harvey, the rainfall greatly exceeded what the flood control system was designed to handle. And so let's talk about the damage that then caused. So the direct storm damage from Harvey was $125 billion. So that works out to several $1,000s per resident of Texas. In addition, Houston is spending billions of dollars to shore up flood defenses. So Harris County just spent $2.5 billion to basically build new flood infrastructure that's adapted for a new world where we get more rainfall. In addition, they're changing housing regulations. So now if you build a house in Houston, it has to be 2 feet above the 500-year floodplain. I'm pretty sure that's right. And that's going to add $11,000 to $32,000 to new construction. So this is going to cost money. Let me give you one more example, which I always find kind of amazing. Loss of value in flooded homes. So I grew up in Meyerland, that's in southwest Houston, just outside 610, right near Braeswood, near North Braeswood, Chimney Rock and South Rice and North Braeswood. And I was looking on Zillow for some houses because this is a region that floods all the time. It didn't flood when I lived there, but it floods now. And I found this house, super nice house, 5,000 square feet, has a pool, really beautiful interior, looks well maintained. The floors look brand new. I'll explain why in a second. I mean, it really looks like it was just remodeled, and it was. And if you look at why the house is so cheap, because $500,000 for a 5,000 square foot house is extremely cheap, because Meyerland's a nice neighborhood, schools are good. And it turns out that the home flooded. Whoops, go back. The home flooded. And it flooded in 2015 and again during Harvey. So it flooded twice in 3 years. And after every time it flooded, they had to renovate the house. So the reason the house looks so nice is because it's flood damage. The people had to spend a huge amount of money fixing up the house. Now, worse than that is what it did to the value of the house. So let's look at this plot. So this shows the assessed tax value of the house. 2002, House was worth $435,000. The value went up during the 2000s. And by 2012, it was worth $500,000. 2015 was worth $700,000. The owners of this house thought, woohoo, we're gonna retire, and this house is gonna be our nest egg. We'll sell it, we'll buy a condo, we'll have all of this money that left over that we can live on. And then it flooded in 2015, and the house value dropped 18%. Didn't flood in 2017, but it flooded again in Harvey. And after that, the house was worth $265,000. So in a space of 5 years or 4 years, it lost 2/3 of its value. And realize this is a loss of real value. If these people were expecting to sell their house and live off the proceeds, they weren't going to do that. They've actually lost a huge amount of value because nobody's going to buy this house. It is not going to suddenly go up in value later. It is deeply discounted relative to what it was a few years earlier. And this is a real loss. And this then can lead, it's a tragedy to one person, but it actually has a big societal effect. So let's talk about a vicious cycle of a neighborhood flooding, then the tax base declines. So for people who may not understand how this works, you pay property taxes. Those property taxes pay for infrastructure like roads and houses, and the property taxes are based on the value of the house. So as houses lose value in a neighborhood, the city gets less money. The tax base declines. That leads to social decay. The schools aren't as good. The roads aren't as good. The sewers aren't as good. You don't repair things that break. That means that people move. Nobody wants to live in a place where the houses are bad. Nobody wants to live in a place where the schools aren't good. People move out. That causes the tax base to decline further. That causes more social decay. Then the grocery stores leave. Then the banks leave. And the gas stations leave. You end up with this hollowed out inner city that essentially the only people left are the people too poor to move because nobody wants to live there. And so this kind of flooding, this systematic flooding, can actually tear apart the fabric of an entire neighborhood. Now, you might be saying, oh, this isn't going to affect me. This isn't going to affect anybody. I haven't had any impacts yet. You know, maybe it'll happen later, and when it does, I'll take care of it before it gets bad. That's not the way it works. Okay, so in the parlance of science, we talk about the damages are extremely nonlinear. So let me give you an example. Let's go back to that house that's next to the bayou. So in 1980, the house never flooded and nobody ever worried about it. Then as the climate was warming, the rainfall started getting heavier. As the rainfall started getting heavier, after each rain, the level in the bayou would go up. But again, unless you're paying attention, you don't notice this. The damage to your house from this increasing rainfall is zero. And then one day, you get a rainfall so intense, it floods the bayou. And then your damage goes to infinity, or it wipes, you know, $500,000 off the value of your house. So this is the way, I'll skip that. So this is the way to think about damage. So as the rainfall gets more intense, your damage is zero until it passes a threshold where the river overflows or something happens, and all of a sudden your damage goes up. So in 2014, the people who own this house were right here. And they thought, climate change, who cares? It's not costing me anything. And then 2015, they're here. And then 2017, they're here. So in a scope of a couple of years, they lost an enormous amount of value. So if you're sitting there thinking, climate change, it hasn't affected me. You know, maybe you're here. Maybe you're here. You don't really know where you are unless you're really paying attention, which almost nobody is. And so don't think that climate change is not going to affect you if it's not affecting you now. It could be in 1 year, you're going to look at this, you're going to say, wow, climate change is really hurting my economic situation. You had no idea a year before because of the nonlinearity of the damages. It's not the case that you will get to a lot of damage over a long period of time by small increases every year. It'll be zero damage and the damage will go up really rapidly. Okay, so we've covered those three. It's real, it's us, it's bad. Scientists agree. I'm just gonna very quickly go over this. We have a statement on our website. Oh, there's hope we'll get to say. We have a statement on our website that basically confirms the things I said. This is unanimously adopted by all 20 members of the atmospheric sciences faculty. If you go to any other university in Texas, they will all agree with this. I know of 0 atmospheric scientists in Texas who would disagree with any of the things I told you. Occasionally people want to have debates. I get invited to debate every couple months, and inevitably they have to fly someone in from out of state to represent the side arguing against this. If you want to support this, there's dozens of people in Texas, credible atmospheric scientists you can find. You can't find anybody to argue the other side. So you'll fly someone in from Canada or Alabama or something like that. That tells you how few credible scientists disagree with this. All right, so now let's get to the last one. There's hope, because I don't want to leave anybody depressed. All right, so let's begin. Before we talk about what we have to do to solve the problem, let's begin by talking about why the problem exists. So it's important to understand, before we get there, it's important to understand that climate change, nobody intends to cause climate change. It's a side effect of economic activity. And so to understand, let's imagine that you are a manufacturer and you're producing coal electricity. And let me say, these numbers are not current, so don't complain that the latest numbers are different. I realize that these are just for example purposes. Let's imagine you're selling coal-powered electricity, and you're selling it for, or it costs you about 12 cents per kilowatt hour to manufacture. Now, as you produce coal-fired electricity, you release carbon dioxide to the atmosphere, and this carbon dioxide warms the climate and costs people money. So it costs Houston money because of floods. It costs Boston and San Francisco money because of sea level rise. It costs Iowa money because of flooding there. It costs people in Dallas money because they have to run their air conditioners more. It costs people all over the world money. And you impose some amount of money, these costs are imposed on the rest of the world from your production of electricity. Now, economists call this an externality. An externality is costs imposed on people who are not part of the transaction. So neither the producer nor the buyer of the electricity pays for it. It's imposed on everybody else. So what this means is the total cost to society is 17 cents, but the manufacturer only pays about 2/3 of that. Okay, the rest of it's imposed on everyone else. So the manufacturer is getting an implicit subsidy from society to produce electricity. So how does this affect the market? Because this has important implications for decisions that are made. So let's compare this to let's say the manufacturer has another option. Manufacturer could switch to solar and wind. Now let's imagine that solar and wind is slightly more expensive than coal. I don't think this is actually true anymore, but there was a time when it was true. But let's just, for the sake of this example, argue that solar and wind are a bit more expensive than coal. Coal, remember, has an externality and imposes a pretty steep cost on society, not just from climate change, but air pollution kills millions of people worldwide and tens of thousands in the US. Solar and wind don't have those externalities. And so if you look at the total cost to society, you see that solar and wind is cheaper to society. So it would be better for society if all the producers switched to solar and wind. Because this is the societal comparison. It's cheaper, you have more money left over to invest or do other things with than if you stick with coal. But this is not what the manufacturer is looking at. The manufacturer is looking at this line. To the manufacturer, coal is cheaper than solar and wind. And so the manufacturer is not going to switch. He's not going to do the socially preferred outcome because to him, coal is cheaper. A lot of the costs of coal are paid by other people because of the subsidy. So this is called a market failure, where the free market doesn't actually make the socially beneficial choice. It normally does, but there are these certain cases that have big externalities where it doesn't do that. And so what this means is that, let's go back. So what this means basically is that we are burning a lot more coal than we should be. You know, I just got a message that my internet is unstable. I'm going to shut off my video if I can. I'm going to stop my video. Let me go back to it. Okay, so hopefully this will. Okay, so put slightly differently, climate change is what happens when we allow people to harm others by destroying their environment without bearing any consequences. And it further says, figuring out what to do is not hard. Fix the incentives. If you want people to do less of something, like dumping their crap in the atmosphere, tax. So let's look at what we can do. What policy can we do that will solve this problem? All right, so here's this is the same plot I showed you before. Here's coal right here, here's solar and wind. And remember, to the manufacturer, coal is cheaper. So instead, let's charge a carbon tax, which is equal to the externality. So the cost of the manufacturer producing the energy is still the same, but then they have to pay this carbon tax. This is the total cost of the manufacturer. So now solar and wind are cheaper because you've made the manufacturer pay the full cost. He's no longer getting a subsidy from society. And in that case, the manufacturer will switch to the socially beneficial, make the socially beneficial choice. So we understand how to solve this problem. And so then the question, and so really, if you think about the choice we face, this is it. We can solve climate change, but it's going to take government regulations. There's no way to solve it without having the government come in and intervene in the energy market. So this is basically our choice. And you can say, I don't like that choice. I wish there was a third way, that there were no government regulations and we still avoided climate change, but that choice does not exist. Okay, so you have to have either government regulations, and if you don't do that, then you're gonna have a lot of climate change. And so what's the argument against government regulations? So there are two of them. First of all, there's philosophical arguments. So Ronald Reagan, since Reagan in the 1980s, we've had this push for small government. And so anytime anybody says, you know, I think the government needs to do this, people say, oh, the government's not the solution to the problem. The government is the problem. You know, not in this case. The government is the solution. Similar for coronavirus. I mean, there are a lot of interesting parallels between coronavirus and climate change in the sense that it's really only the government that can solve the problem. The free market will not make sure everyone has a ventilator. And the other reason, which is, I think, more important now, is basically grift. So corporations want to push costs onto society. So we talked about the externality. They love that. Why would you pay to not pollute when you can just push those costs onto society? And in fact, let me give you a more concrete example of this. Talk about the Clean Air Act. So Los Angeles in the 1950s, this is what it looked like. It was not a great place to live, for your lungs at least. And we've cleaned it up. We cleaned it up not because of the free market, not because emitters were, not because consumers were forcing the free market to emit less, is because of government regulation. So that's why we have clean air. Now, if you look at the benefits and the costs, people have tried to monetize the benefits and costs of less air pollution. And what you see is that regulation costs money. There's no question about it. And reducing carbon dioxide emissions may also cost money. It may not cost a lot, but it's going to cost some money. And if you look at it, $65 billion, like, wow, that's a lot of money. That's job killing. That's taking money out of my pocket. But you also get benefits. And usually when people talk about the costs of regulations, they don't talk about the benefits. If we look at the benefits are enormous. The benefits vastly outweigh the costs of climate change, of the regulation that has cleaned up our air. And so you might look at this and say, why would anybody oppose this? This looks like a slam dunk, $2 trillion of benefits for $65 billion of costs. And the reason is that the benefits are distributed widely through society. So everybody benefits. And the people who pollute, they benefit a tiny bit. They get one, in the US, they get 1/300 millionth of the benefits. But the costs are paid entirely by polluters. So the $65 billion are entirely paid by a very small number of extremely powerful people. The $2 trillion are widely distributed among everybody. And so to the polluters, this is a terrible deal. And so the polluters completely own politicians. And so this is a quote from a representative from Oregon who's actually retiring. And this is what he says, regulations imposed $15,000 per household from the federal government just in 2015. That's terrible. And all he's doing, it's important to understand, all he's doing is looking at the costs. And, I don't know if regulations are $15,000 per household. Maybe they are, but you get much more benefits from that. But again, a lot of our politicians are completely bought and paid for and owned by corporate interests. And so it is only the corporate interests that they're actually representing. And to them, these policies are bad news. So when you sum right up, you get back to it. This is actually my last slide. Let me just sort of review what we've talked about. So climate change, it's real, it's us, it's bad. I hope you appreciate, at least that's what scientists think. We know how to solve this. Polluters have to pay. And if you do that, that's actually the cheapest way to solve the problem, but it requires government regulations. Polluters are not going to pay without it. And this will require us to reevaluate the role of government. Right now, if you go talk to many of our representatives, you say this, they'll say, oh, government's bad. Get the government out of our economy. But if you do that, then you're stuck with climate change. I mean, that again is your choice. There is no other choice. And I think you see also in the coronavirus thing we're living through, the value of strong public institutions, that there are certain problems which only the government can solve. And this knee-jerk response we have that government is always bad is not correct. I mean, government is not always bad. There are certain problems that only the government can solve, and this is really one of them. But it requires us to reevaluate the role of government, and it requires our elected officials to not be just doing what corporations tell them to do, to actually look at society, look at their actual constituents, as opposed to corporations. And I'll end it with a quote from an article I read in the New York Times last year, which I think is right. It's that when capitalists perceive government as an ally rather than a foe, when all citizens have a stake in high quality public institutions, it's amazing how well government can get things done. And we've really come a long way away from that. Many of our elected representatives, their main goal is to make government fail. And again, with coronavirus, you see we are now sowing the result of that. We don't have enough ventilators. We don't have enough tests. There is no coherent plan. But stronger public institutions will help us with pandemics, will also help us with climate change. And so I think this is really the debate we need to have. Anyway, that I'll end, and I'm happy to answer questions. Thanks. The problem with these talks is, for all I know, everyone else is disconnected. I'm talking to myself.
No, you're definitely not talking to yourself. Would you mind dropping your screen down, Dr. Dessler?
Sure. I will. Hold on.
Yeah, thank you for that. You gave me plenty of. I was furiously scribbling notes myself. It's always certainly a pleasure to hear you speak. All right. The first question I've got for you is, how do you see COVID-19 impacting governmental actions on climate change in the coming years?
Well, I think it should be. I think it should be a wake-up call and demonstrate the importance of strong governmental action for this small subset of problems that the private sector can't solve. Climate change is certainly one of them. I would put healthcare also. And these kinds of, we already understand the military. We need a strong governmental military. It's just like that. There's a small class of problems that the government has to solve. And I hope people recognize that. I mean, what worries me is, the people who are opposed to government intervening in the markets are going to be fighting that tooth and nail. And they're already saying that, look how wonderful the response is. And, it goes to show you don't need the government. So we'll see.
Great. While I'm waiting for more, I've got a question. So you spoke to me in a lot of different ways. And one of the things that I wanted to ask you a little bit more about is the nonlinearity of damage. I thought that was a really great example. And then I'm thinking about, I've had family members myself impacted by those floods that you were speaking about. But what happens when people go from, they don't know that they're in trouble and then all of a sudden they are, but what happens, or how do we communicate with them? Because I've encountered folks that still don't recognize I've reached that point, but they don't make the connection to climate change. It's something else.
Yeah, that's, I often get that question. How do you convince people? And, the short answer is that it is extremely difficult to do that. People at this point, they view climate change as a tribal signifier. So if you walk into a room of Republicans and you want to prove that you're a good Republican, you just say, oh, climate change, it's a hoax. And in that case, it's really hard. It's like convincing somebody that, convincing the Pope that, Jesus was, didn't die for his sins. I mean, these things are they're not rational constructs based on evidence, but they're based on tribal identity and things like that. And I think it's really an interesting academic question, how we got there. I don't know if that was actually someone's goal or if that's just the result of it. But, I think that the good news is there are not a lot of people who really are angrily antagonistic to climate change, maybe 10 or 20% of the population. And I think that if you run to someone like that, you don't really try to convince them. You work on people who are sort of in the middle, disengaged, maybe haven't thought about it, sort of draw the conclusions for them and try to convince them. I think that's what you have your better chance. The one thing that does not work, I can tell you with 100% certainty, is trying to give them more facts. That absolutely doesn't work. You can show them all the data you want and they'll say, oh, that's a hoax. Those people are in it for the money. They're lying to you. In fact, if you keep showing data, they'll get angry at you. And they'll say, well, you're part of it. They'll eventually say you're part of the conspiracy. So that does not work. So you just don't, I don't engage with people like that. And try to engage on people that haven't thought about it, that may not have a strong opinion.
All right, we've got another question for you. So do you think COVID-19 is having an impact on the environment because everyone is staying home, so there's less pollution in the world?
I think we will find out when people start doing analyses on that, but certainly anecdotal evidence suggests that we are. Satellites are showing that there's less, when China was shut down, there was less air pollution. And so it seems quite likely, fewer planes flying, that's going to have an effect. I don't know. It's clearly not going to be a permanent effect. I mean, this is all going to come back. So I don't think that this doesn't fill me with joy because I think any benefit that we're getting from the environment, from the short term, really temporary environmental impact is going to be swamped by much longer term economic damage. The environmental benefits will be quickly reversed. The economic detriment will take a very long time. It may take 10 years to get out of that.
Thank you. With the carbon tax having been roundly criticized, what do you think is the chance of it being accepted in the future? There's multiple parts to this question. Have you heard of Ecosystem Services Marketing Consortium put together by major food producers? And do you think it does something different than the first attempt at sea markets?
Yeah, so, I don't know. I think right now there's no chance of getting a carbon tax in. I would have thought that, you'd always hope that an economic calamity, you'd be able to get some benefit from that. And people would realize, with this coronavirus, maybe the government should step in and handle some problems. I just don't know if that's actually going to happen. Maybe if we're far enough in debt, people will say, well, carbon tax is a way to raise money. We'll see. I mean, as of right now, there's zero chance until you get 60 votes in the Senate. You can't get anything through there. I have not heard about ecosystem service markets. Sounds like a good idea if you're actually trading, if you're trying to monetize these positive externalities we get from, bees pollinating is this positive externality that we get from nature. I think it's a great idea to try to deliver essentially property rights for that. That's essentially what a carbon tax does. And I think it's a good idea, but I haven't heard about that. But more power to whoever's trying to do that.
Curious, what are your thoughts on kite energy as a form of renewable energy, and how do we move forward with adoption?
Yeah, I've seen that. A lot of these energy sources clearly work, but it's just a question of scalability. Can you build enough of it to give you terawatts of power? Right now, humans use about 15 terawatts. Whatever it is, has to give you terawatts of power. Those kites, I think those are sort of the megawatt. So the question is, can you build, 50,000 of them? We know we can build that many windmills, sort of traditional wind turbines. Maybe we can build kites. I think, certainly look like a good idea, but until you look at the economics, you don't know if that's going to work.
What are your thoughts on animal agriculture being the highest contributor to greenhouse gases? And do you think it's important to focus on that or less fossil fuel consumption? And thank you.
Yeah, I don't think that's right. I think fossil fuels are the biggest contributor. Agriculture certainly is important. It is a big one, and politically it's extremely hard to cut down emissions from there. The farmers, at least in the US, are an incredibly powerful market. Iowa is the first presidential primary state, and that actually, because of that has all of these really important policy implications, because anyone who goes to Iowa has to support all of these crazy farm policies that then they're stuck on if they want to get reelected. It's really hard. It's really hard to control those. But I do think it's crucially important for us to get farmers on board and for us to figure out ways to limit carbon without, obviously you need food. You can't stop agriculture. So you need to figure out how to do it, but you also do need to reduce emissions because it is an important source.
Beyond taxing pollution after the fact, do we know what effect discouraging extraction of resources in the first place might have? Or are there any theoretical mechanisms to do this? For example, make extraction too expensive to be attractive?
Well, that's what a tax does. So you apply the tax at the wellhead or at the mine, and then you let the costs ripple through society. What you want to do, in fact, if you put a tax on carbon that was actually equal to the damage it's doing to society, you would wipe coal out. Coal would just stop, except maybe for steel production. There's a few uses of coal you can't replace. Metallurgical coal is one of them, but essentially you would wipe coal out. And so that's essentially what a carbon tax does. I mean, it shifts the incentive so that people will use less fossil fuels. They'll switch to, everybody wants to switch to the cheapest energy source. That will be wind or solar.
How is the USA doing in terms of fighting climate change compared to what other countries are doing in the world? And what can we do better or different to continue improving?
Well, if there's a country doing worse than the US, I would like to find them. I was actually looking, North Korea has a climate plan to reduce emissions. So, to say we're lagging behind North Korea in climate ambition is telling you something. Now, granted, North Korea does have an ambitious policy, but they do have a policy. So, we're not doing anything. Really not doing anything because we're a country that's ruled by corporations, and they would much rather push the costs of climate onto society than have to pay them themselves and reduce their bottom line, even if society is much better off with that.
How much individual responsibility, as opposed to waiting on government regulation, do you think citizens should take in terms of reducing one's carbon footprint?
That's a super interesting question. So there are really different ways to think about it. And I would say that from a carbon standpoint, there are lots of things that individuals can do to reduce emissions. So you can eat less meat, you can walk instead of drive your car, you can, lots of things you can do, fly less. None of those things will actually make a big difference in the long run without government policy to switch the way we generate energy over to renewables, like a carbon tax. So really the only, and you need an international agreement where everybody agrees to do this, all the countries in the world. And the only way to do that is with government policy. So on the one hand, individual virtuous actions, you should do them. They'll save you money. You'll be healthier if you eat less meat. You do not lose if you do those, but those aren't going to solve the problem. You really need to work to elect representatives who support your position on climate, if that's something you care about. On the other hand, I've seen research which suggests that taking virtuous actions does help convince other people. And I'm always reminded of Greta Thunberg. She wanted to go to the UN meeting in New York and she didn't want to fly, so she took a boat. And, you look at that and you think, okay, she's walking the walk, or she's walking the talk, or whatever it is, however that saying goes. She's doing what she says. She's modeling good behavior. And I think that she's really an amazingly powerful messenger because she has a lot of moral authority. And so I think I encourage everybody to do individual virtuous actions as a way to get to the thing that will actually solve the problem, which is national international policy, which is what you really need.
All right. Well, thank you once again, Dr. Dessler, for this very, I think, not only informative, but a very accessible talk about climate change. I certainly appreciate the way in which you frame that conversation to, make it very relevant.
You're welcome. Well, thanks for the invitation.
Well, that's one of the benefits of this kind of awkward time is we've actually been able to think a little bit differently about how we do business, and we're glad that you were available to not meet us where we are, but meet us on the screen here. For those who have joined us, we really appreciate that you were here today. I want to remind you that our Virtual Earth Month continues. We have our next talk at 5:30 this afternoon, and it's going to be one of our student sustainability interns talking about the housing crisis on COVID-19. Also want to give a plug that tomorrow morning at 11:30, we will be hosting a virtual sustainability award ceremony for individuals on the Texas A&M campus. So you can find out more about those events at sustainability.tamu.edu. And with that, Dr. Dessler, thanks once again. We appreciate you being here today. Have a great one.
Bye.
Bye.